We should probably go ahead and start. See if more people trickle in.
Hey everyone, good evening and welcome to the second meeting of Artificial Intelligence and Machine Learning Club at Virginia Tech. Today we're going to cover Introduction to Neural Networks and hopefully we'll get time to make a couple models. Take a look at contents. So firstly, I want to discuss about the semester plans that we have planned until now. So most of this are tentative, but if they'll change, we'll inform you. So today we're going to introduce neural networks, and if we don't complete, then this meeting can continue on the 1st of March, and we'll make 2 projects. First project will be image recognition, which basically we'll make a model that can identify an image and put it into a class, as in like a cat, a dog, or horse, and different classes based on the CFAR 10 database that they have. It's a public database available to everyone. And secondly, we're going to make a COVID mask detector, which is going to tell you whether you have a mask on or not. And on the 8th of March, we're going to have guest speakers from Deep Cognition Inc., which is like a growing company. It's a really good like company with like huge potential to grow. So basically what they do is I can see my screen share. So if you guys are familiar with Wix, so you know how they basically have like website making, like you don't need any skills to make websites. So what Deep Cognition does is they basically have a software, Deep Learning Studio, which is basically like Wix, but for ML. So you don't actually need to hard code anything if you want to make ML models. It's not really for beginners. It's made for engineers. It's a really good software. Basically like Wix, but for AI. You can like download it for free right now, but they're going to be here on the 8th of March, and our team is planning something like really good. We're probably going to have prizes and stuff as well to go with it. So make sure you attend that meeting. It's going to be a good introduction to the real world applications and real world company and how they do, and the AI scene in like the actual professional world. And on 15th March, we have scheduled an Orange demo by Dr. Miller. He is very resourceful and intelligent. He got his undergrad, graduate, and PhD from Virginia Tech, and he graduated his grad school at Virginia Tech with a 4.0. So he is really resourceful. And he's going to teach you about Orange, which is like a data mining and visualization software. It's really helpful if you're doing anything with computer science. It really helps to like align everything and like plan everything out. And on 29th March, we have a guest lecturer, Kasim, if I pronounce that correctly. He's also insanely intelligent and passionate about teaching. Currently, he is doing research with UC Berkeley, Columbia, Virginia Tech, and one more fellowship. And he has made an ML model that has an acquisition for $20,000. So he is also very resourceful, and it's going to be a good opportunity to attend that one. And on 12th April, we also have one more resourceful and passionate guest lecturer, Alexi. And on 22nd April, we have a joint meeting with Association of Women in Computing. The 22nd April meeting is the only meeting that's going to be on a Thursday. Other than that, all other meetings are on Mondays at 6 p.m. The 22nd April is also going to be fun to interact with other fellow members at Virginia Tech. And our last meeting is going to be 26. We're going to discuss some fun networking activities, and we're going to have plans for next semester. And so now let's just start into it. So basically, let's just understand how computers view images. So how human brain views images. Like if I see something, how can I say that it's a blanket? Even if it's like every single day when I wake up from my bed, I can know that that's a blanket, even if it's like a completely different shape, or if it's deformed, or if it's like crumble, or like inside out, doesn't matter. My brain can tell that it's a blanket. If I see 2 apples, which are not identical, my brain can still tell that those are 2 apples. So how do we see images? So what our brain does is it analyzes its features, it recognizes its physical properties, and based on that, it tells you that this is the apple or this is the blanket. Even if let's say you have a friend who's not looking at you, you can still tell people, or you can still recognize him, even if he's not looking at you, even if he's like not making eye contact with you, even if he has a different clothes, even if he has different glasses, different hairstyle, because you analyze physical characteristics and make predictions based on that. So basically, how computers view images are nothing but a pixel value, right? So images are made of pixels, and each pixel has a value. If the image is black, the pixel value is 0. If it's white, the pixel value is 255. So it has 256 different pixel values depending on the color of the image. So what computer sees is just basically numbers aligned in a 2D matrix. And how computer views color images is basically it's three matrices. It has three matrices, but it's just three 2D matrices, because a color image is nothing but just a black and white image, but with an RGB value. So let's say this is the image. So for this image, the corresponding RGB value is it's going to have some value of red, some value of green, some value of blue, and it's going to be the addition or the summation of all the three matrices, and that's how we see this image. Basically, the first element of the matrix is going to be 8. It has a red value of 8. The first element of the green matrix is going to have a value of 15. The first element of the blue matrix is going to have a value of 14. And the first element of this 2D matrix is going to have RGB value of 8, 15, and 14. It's a combination of all three values. And that's how basically computers view images. Now, how do computers recognize numbers? So basically, when it sees a 9 or an 8 or a 4, it breaks it down. It breaks it down into small parts or small features. As in, a 9 is just a circle plus a line. 8 is just 2 circles. 4 is 1 horizontal line, another, and 2 vertical lines. 1 horizontal line and 2 vertical lines. That makes a 4. So computer view that. Now, how can a computer recognize whether it's a circle or a straight line? So it also breaks that down into different parts. Is it a combination of all these all these 5 circular parts, or is it a combination of all these 3 vertical lines? So that's how it recognizes a 0 and a 1. And now, so basically, how computers recognize numbers, or how neural networks, which you can see here, recognize a number, is basically it takes 284 input values, which 74, my bad. 74 we get because the image is 28 by 28 pixels, so we get 784 different values corresponding to the pixel depth of this image, number 9. It takes this image, it breaks it down into smaller features or smaller deformations. It's like it sees that there's a smaller circular edge, there's one more circular edge, there are a couple of straight lines, and it's gonna break it into that. And the corresponding neurons are gonna get fired up. And after it sees this, it's gonna finalize this into, oh, it's a circle, and I have one circle and one line, which is aligned like this. So these 2 neurons are gonna get fired. And at the end, the program's gonna tell you that it's a 9 because these 2 neurons got fired, and the attached weights give us high probability for this one. So for this layer is an input layer, which basically has input value. This is the output layer, which has output values, and the layers in between are basically hidden layers. If this is way too complicated, we're gonna learn about this today, so don't get overwhelmed. And so let's learn about neural networks.
Yeah, so you saw from the last picture, that was a pretty complicated neural network. It has inputs, and then it has like the hidden layers in between, and it has the outputs, and there's so many lines in between that you don't know where the lines are going. So obviously the neural network is modeled after, your brain, which is like a biological neural network. And basically, as a human, when you look at stuff, anything, input, smell, taste something, you take in data, you learn, and you improve yourself. When you're growing up as a kid, you learn how to walk, you learn, how to balance yourself, and you continuously improve and make predictions. And that's how the neural network works. And it's made up of perceptrons, and the perceptrons are, as you can see in that bottom left of the slide. Janet, go back. the bottom left of the slide, that's like the perceptron, the orange one, and it's taking in input from the two yellowed ones, and it goes into the perceptron. And on the right, you can see kind of like a basic neural network where the inputs are going in, going to perceptron, and you get an output. You can move on. Okay. Yeah, and like I said, yeah, the perceptron is like the basic unit of a neural network, the atom of a neural network. And essentially what a perceptron is, it's a small function that takes in a number of inputs. Like I said, it does some processing with those inputs and it produces an output value, which is also known as the activation value. And the activation value is how much the network, the neural network, how much it thinks is true. So if we're talking about the example Janet mentioned earlier, talking about the number 9, basically a neural network looks at that and it gives a value and it tells you how close is this to a 9 or not. And so the activation value, obviously that's the important number we want. So we want to be able to comprehend that number. So that's when an activation function comes in. And the activation function sort of acts like a gatekeeper that checks an incoming value to see if it's greater than or less than a certain threshold. So when we're looking at an image to see if it's an, like an apple or not, we want that to be like, let's say between like a range of 0 not being an apple to 1 being an apple. So we can kind of comprehend that number and see what it really means. And so right now in CS and like machine learning, one of the most popular activation functions is ReLU, which stands for rectified linear unit, I believe. And it's that bottom left one on the image to the right of the slide. And you can move on, Jim.
Yeah, so basically, how does a machine learn or improve itself? Because we've looked that a machine can make predictions of a 9, but what if it makes prediction of a 4? What if it thinks there's a 0.5 chance that it's a 4 or 0.5 chance that it's a 5? How does it make predictions? So basically what we do is we calculate the cost of the output. So cost of the output is basically just predicted value minus true value, and you squared it. It's sum of all predicted values minus true value and square of it. So basically, if the program thinks that this is the possibility of this being a 0 is 0.3, then predicted value is 0.3 minus the actual value 0 because it's a 9, and you square it. So you square and you sum all the cost functions. And whatever the cost function you get, the goal as a developer is to minimize the cost function. So you need to make sure that the cost function is at the least to improve. So how do you minimize the cost function? So you can use negative gradient descent because it gives us the direction of the steepest descent. And you can also, this also informs the program how to efficiently decrease the cost. So basically, if you have a random value of a weight or a bias over here, it's going to look at your goal is to find a minimum, a local minimum or a global minimum. And it does that by calculating negative gradient and going this way, one step by step. So as your program runs, it gets better at predicting because it's going closer to the minimum value. And this is the math related to it. The math it can get really complicated. So there's a 3 blue, 1 brown YouTube link over here if you guys want to check it out. And I'm available in Discord if you ever want to talk about the math, because as a double major in math, I love the math behind it, and I think the logic behind it is fascinating, but I guess that it's going to be boring to a lot of people because it's deep math. And also, if you think that this is way too complicated, as long as you've taken differential equations and linear algebra, you're going to be good. You're going to understand everything. So this is the link if you want to check it out, and I'll be in the Discord meeting rooms if you want to discuss about it.
Yeah, and we'll also get these slides out to you guys after the meeting, so you guys can access the schedule and the links in here. But yeah, continuing off of that, so here in the image you have the perceptron on the left and the feed forward, which is basically one of the first and simplest types of a neural network that was ever kind of made up, because there's 2 perceptrons, 2 inputs, and 1 output. And in this network, the information moves in only one direction, so it's called feed forward. And as you can see, there's really no cycles or loops in the network. You can move on to And so here, these images are kind of self-explanatory, but I'll kind of, guide you guys through them. So there's here we're kind of seeing the acceptance out of a university based on grades and your test grades. I believe it's for your SAT, and the red dots represent those who got rejected to university, and the green dots are those who got in. So can you move on? Okay, and so there's two lines, one line being the blue line, one line being the orange line. Those represent questions. So the first question is this point over the blue line? The second question is over the orange line. And if if the answer to both questions is yes, that basically means that they, got into the university. But what do the lines represent? They have to represent something. You have to be able to base it on something and be on one side or the other side of the line. And can you move on, Jenna? And what the lines represent, as you can see here, is it's taking in the input of the SAT test score and your grades, your GPA, and it's the perceptrons are seeing if your SAT or your grades are above a certain threshold or below a certain threshold. So it's telling it if it's above or below the blue or orange line. It takes in both those outputs and asks the question, will you be accepted into university? And that's your final output. Jenna, you're muted.
So let's look at the different types of neural networks. The one we learned right now is just a basic feed-forward network. Say simple, just goes from left to right, doesn't have any back propagation. So these are all the different, so there are a lot of different types of neural networks, and this is just a few of them. But if you look at, there's the whole entire dictionary of neural networks. So the perceptron is the atom of neural network. Feed-forward is just a basic group. So different neural networks are used for different stuff, as in the recurrent neural network, what it does is it loops back to and has back propagation and loops back to it. So it can be used for music composition or generating text or speech recognition or text summarization. LSTM also does that. However, it also has it's basically long short-term memory, which has a memory cell. So it can also be used for similar purposes to that of RNN, but more advanced because it has more memory. And autoencoder is also really widely used because it encodes the data and then decodes it. It could be used if you have a large sum of data, you can summarize into a couple of variables and understand from it and extract the features. And the main network that we're going to learn about today is convolutional neural network, because we believe it's one of the most important networks, and especially in today's world, because it has a lot of applications. First of all, it is used in autonomous vehicles, facial detection, medicine, biology, text, image, or video recognition, and all that stuff. It basically is what gives computer vision, because what it does, it looks at the image, looks at its features, and extracts data from it. Now, before I move forward, does anyone have any questions so far? Okay, if you have questions later on, you can always just DM us or write in the general chat in the Discord. So now, this is the basic model for convolutional neural network. Basically, it takes input as a picture, and puts it into feature learning, which basically learns its features and then classifies it into softmax, which is basically different classes, and identifies if this is a car or a truck or a van or a bicycle. So basically how it does this is convolution layer, it makes layers. So how we look at the first example, it basically takes this line and takes it into small regions, which is basically, does it have a horizontal line, a vertical line, a curved line? Where's that line? How is it oriented? And it puts it into the second layer, which basically gives a little bit bigger region, which is, does it have a circle? Does it have a long or short horizontal line or vertical line? It basically tells us about its features. So now, if a computer looks at this X, and if a computer looks at this X, it needs to how can it recognize that this is both the same image and not different image? Because if it looks at the pixel values, there's a white pixel value over here and over here, when there's no white pixel value over here and here. What it does is it looks at small features. There should be a center X and there should be 4 lines at the corner of it. And the similar, it compares over here, there is a central X and there's 4 lines connecting to it. So it's going to make a prediction that it's likely that this both pictures are the same. Now, how do we extract features? So first of all, we cannot extract features manually. We cannot tell the program that, oh, here, if it has an X over here, we cannot tell the program that it has an X in the center and then 4 adjacent lines. Why can't we do that? Because it has a lot of limitations. Because if there's a scale variation, like this to image is similar, but it has a lot of scale variation. If there's a viewpoint variation, as in if the picture is, the person in the picture is looking somewhere else, if there's a deformation in the picture, if there is in-class variation. For example, if you had to identify a chair and there are a bunch of different chairs out there, so there's no way the program could identify one as a chair because it's not, because as a feature, you can tell the program that if a chair is black, then it's a chair, but if when it sees a red chair, it's not going to understand what's happening. And there also could be background clutter. So basically, if you tell the program that a banana should be yellow, and if it's in the yellow background, it's not going to know the difference. So it's not going to give accurate predictions. So
we get to the convolutional layer, which is essentially, you know, what the convolutional neural network is. And as Janet was just talking about, the important part of it is the feature extraction, getting the features from the image to be able to classify what the image is. And so what we do in this convolution layer is basically, it's linear algebra. So when you're looking at the image, we convolve or multiply a small area within the image. In this picture, the image would be the one on the left. And we multiply that small area with a filter, which is the one on the right. And we record the output in another matrix, which tells us which features were extracted. And you'll see kind of, we have a GIF in here that kind of explains that more visually. And as you can see, we're multiplying certain areas of that matrix and moving forward, putting that into another matrix. And we get to see from the filter what features we get from the image or that. And yeah, this is just kind of explaining what I just said. The image, we multiply that 3x3 matrix filter over the said image. And, you know, we add the out, we do some math and get the feature map. And as you can see on the right, there's various filters. You know, there's filters, you know, identify the image. There's filters for edge detection, which I've seen. As you can see, there's also like filters for sharpen, box blur, Gaussian blur. But yeah, the filter is kind of one of the most important parts of the convolutional layer because it kind of tells you which features you want to extract and what you want to get from the image, and that kind of affects your final results. And so we also have a pooling layer, and essentially what the job of the pooling layer in the convolutional neural network is, it's to reduce the input size while keeping the important parts or features of the image. And as you can see here in the second line, basically it's performing a downsample operation of the image. So we can still keep the important parts of the image. So we're not taking in as much data and using as much space, which, you know, can eventually make the convolutional neural network a little big, slower, etc. And here's another GIF just kind of showing what the pooling operation does, which in here is taking it's a max pool, so it's taking the maximum value of the image or the input and putting it into another matrix, and it keeps those important values into an output matrix.
So there are 2 types of way you can pool data. One of them is max and one of them is average. In max, you take the max value of all the 4 little boxes, you take the max value, and in average, you average down the 4 values. But in practice, it's more efficient if you take a max value, you get better ML models. So it's usually what we prefer. And to summarize CNN, so basically it has an input, which is a picture. It takes a small block of the picture, it analyzes it, it puts it into a filter, adds a activation function, and finds out whether it has certain types of features. And now this is how it does it through convolutional process, which is a matrix, finds a filter, gets a feature map, and then puts that into a max pooling process, which basically gives us the max pool of the matrix. And it does it over and over and over and over again, as many convolutional layers as we have, and then finally gives us the output, which is basically fully connected layers of softmax with telling us what class it belongs to. For example, if this, for example, let's go all the way. For example, if this is 9, there's white spaces over here. So all the neurons corresponding to those white spaces are going to get light up. So basically, they're going to have a higher value. So those values are going to be 1, and the spaces over here, which is dark, are going to have 0 value. So when the 1 value gets multiplied by its corresponding weights, it's going to light up this up and this up and this up. This values are corresponding to this small features that it has. Let's say this value is a 1, so it doesn't have, it's a dark value, so it has a low activation value. So it's going to get multiplied with its corresponding weights and biases, and it's going to go over here. This is also going to have a low value because this had a low value. And all neurons depend on the neurons before that. And so this is going to have a low value because this had a low value, and this is going to have a high value because this is going to have a high value. And now the combination of all this, which goes to over here, is going to have a high value because all this had a high value. While this is going to have a low value because this might be a combination of all this, and the corresponding weights that corresponds to this and this would be lower. So let's say if this was 1 multiplied by a weight of 0.01 is going to be 0.01. So this is going to be closer to 0. And over here, let's say the value of this is 0.5, but the weight corresponding to is 1.5. So the value of this will be 0.75, which is a high value. And now when this 2 gets multiplied by its corresponding weights and biases, it's going to tell us that this is a 9, or this has a high probability of being a 9. So we might get this probability as 0.9. This we might get 0.01, 0.02, 0.0001, or something like that. So basically, that's how the neural network forms, and that's how we learn from images. And yeah, to summarize this is again just the same picture, which basically takes an input, performs convolutional layer, applies the activation function, which here they took in ReLU, and then they do pooling, and they do the same thing again and again until they get the last layer. And over here, when they flatten the data, flattening the data is basically taking a 3D matrix or a 2D matrix and putting it into 1D matrix. So there's only one line of numbers. So it's easier to make connections and it's easier to analyze everything. So when we have a flattened data, and it's easier to convert it into a softmax, which is probabilities of every single class. Rather than seeing like a matrix of values, it's easier when we just have 10 values or 10 probabilities of how likely is it that this is a van, this is a car, this is a truck, or this is a bicycle. So until now, do you guys have any questions? No questions, okay. So this is a couple of resources that you can look onto that explains pretty well. This one, CNN Explainer. I think Colin showed this last semester also. It basically takes pictures and tells us what every single layer is doing. So this is a convolutional layer. This is analyzing for something. Then this, the add activation function. There's another convolutional layer. In max pool, then another convolutional layer, and finally you get this. So they take this image. There's a different types of values to attend it. There's the RGB values, how strong the values are. They extract different features from it. Let's say there's a let's say for a pizza. So they take RGB values of a pizza, they analyze something, they take one more feature, then they take another feature. So this is the corresponding values to it, and finally you get this. So if you like play with it, it tells you how it shows you a good graphic to it if you want to actually play with it. And this is a really good series if you're into math. It explains the logic behind neural networks really elegantly and shows the math behind it. And MIT Introduced Deep Learning course is also really, actually the MIT course is going on right now. If you guys want to join, it started in February or March, I think. It started in no, my bad. It started in January and it's going to go all the way to May. So if you guys want to join, and they post weekly videos every Friday or something. So if you guys are interested in doing that, I recommend that. And now, are there any questions? So we can, okay, first of all, I wanna apologize to all of our old members because this might be a bit repetitive if you've done all this with Colin last semester, but we had to do this because we had to catch the new students up to the pace so we can move on to more better projects. This is just a basic introduction. So now hands-on projects, basically, the last thing, we're gonna make two models. One model is gonna classify images, another one is gonna wear a mask. Today, I'm thinking today we're gonna make the classification model, and if we have time, we're gonna go on to the wearing mask, or we're gonna save that to next meeting. An open question to all of you: do you guys want to make the models today, or do you prefer if we make both models on our next meeting? If you're overwhelmed by information, we can do both of them next meeting as well.
How long would it take to do just the first one? Because we got, I don't know, 24 minutes or so.
It's gonna take 10 minutes or so to compile because it usually takes a minute to compile every single time it runs, and we're gonna run it at least 5 to 10 times. So it's gonna take 5 to 10 minutes to compile, and it's gonna take another like 30 minutes to code and explain the code. So let me see what the chat is saying. Yeah, that's a good idea. I can do a poll. I can stop screen sharing. For some reason, it's not allowing me to create a poll on Zoom, so I'm just gonna use a third-party app to create a poll. Oh yeah, so for the collab link, so the collab link in the PowerPoint right now is just to the website of the Google Colab. So you're gonna go to the website, but I'll share my link so you can like follow along myself as well if you want to do that. And the code that we're gonna practice today is on our GitHub, so you can do that as well. Yeah.
Please do the poll. There's 20 of you here, so I expect to see 20 results. I'm gonna be mad if I don't see anything.
You don't want to see Jonathan mad.
Don't. Yeah, I mean, it's looking like they want to do it next meeting because 3 people haven't done it, but those 3 people aren't going to change the vote. So, yeah, I mean, yeah, for sure, we can save it for next meeting, and that works out better because we can, obviously go in a little more detail with the actual
Yeah.
code itself, and we can actually explain a little more if you guys have questions.
Yeah, I'm gonna stick around if someone has a question or something. But you guys are free to leave if you want. But if you guys want to learn more, have questions, ask questions, feel free to do that as well.
Yeah, for sure. Yeah, thanks for coming out.